Algebra of Derivatives. Hello everyone. To begin, let's look back at what we have already covered. In our previous sections, we focused on the fundamentals of how to find the derivative of a single, standalone function. However, it is important to realize that in practical mathematics and physics, we rarely encounter functions that exist in isolation. In real-world scenarios, most functions are actually combinations of simpler functions, meaning they are often added, subtracted, multiplied, or divided by one another. This is why we are now introducing the algebra of derivatives. This topic provides us with a set of formal rules that allow us to differentiate these combined functions efficiently. By mastering these rules, we can find the derivative quickly without having to rely on the long and tedious first principle limit definition every time. Throughout this lesson, we will explore these rules in detail, starting with the sum and difference rule. 1. The sum and difference rule. Now that we understand why we need these formal rules instead of relying on the first principle limit definition, let's dive into our first set of rules. We will start with the sum and difference rule, which is arguably the most intuitive of all the algebraic rules we will cover. Essentially, this rule tells us that if you have two functions added together or subtracted from one another, you can find the derivative of the entire expression by simply finding the derivatives of each function individually, and then adding or subtracting those results. To put this into a formal mathematical statement, if we have two differentiable functions, u of x and v of x, then the derivative with respect to x of the quantity u plus or minus v is equal to the derivative of u with respect to x, plus or minus the derivative of v with respect to x. You might also see this written more concisely using prime notation. In this form, the derivative of the quantity u plus or minus v is simply u prime plus or minus v prime. This simplicity makes it a great starting point, and in the next slide, I will walk you through the exact step-by-step process for applying this rule to a problem. Step-by-step application of the sum and difference rule. Now that we have established the formal definition of the sum and difference rule, let us look at how to apply it systematically. To ensure accuracy, I recommend following these 4 clear steps. First, look at the expression you are differentiating and identify the individual functions, which we refer to as u of x and v of x, that are being added or subtracted. Second, focus solely on the first function, u of x, and find its derivative independently of the rest of the expression. Third, perform the same process for the second function, v of x, calculating its derivative separately. Finally, combine these two individual results using the original sign, whether it was a plus or a minus, from the original function. By following this structured approach, you can avoid simple errors. To see exactly how this works in practice, let us move on to a concrete example in the next slide. Example for sum and difference rule. Now that we have discussed the theoretical steps for the sum and difference rule, let us apply them to a concrete example to see how it works in practice. We are asked to differentiate the function f of x equals x cubed plus sine x. Following step 1, we first identify the individual functions that are being added together. In this expression, we can let u equal x cubed and v equal sine x. Moving to step 2, we find the derivative of u independently. Applying the power rule, the derivative of x cubed with respect to x is 3x squared. In step 3, we find the derivative of v, as we know from our basic trigonometric derivatives. The derivative of sine x with respect to x is cosine x. Finally, in step 4, we combine these two results using the original addition sign. This gives us our final answer. F prime of x equals 3x squared plus cosine x. As you can see, the sum and difference rule is very straightforward because it allows us to treat each term as a separate problem. However, be careful not to assume this same simplicity applies to multiplication, which is what we will explore in the next section with the product rule. 2. The product rule, Leibniz Rule. Now that we have covered how to handle addition and subtraction, let's move on to multiplication. It is very important to realize that when two functions are multiplied together, we cannot simply multiply their individual derivatives to get the answer. Instead, we must use a specific formula known as the product rule, which is also referred to as the Leibniz Rule. To put this into a formal statement, if we have two differentiable functions, u of x and v of x, the derivative of their product, u times v, with respect to x, is equal to the first function u multiplied by the derivative of v with respect to x, plus the second function v multiplied by the derivative of u with respect to x. If you prefer using the more concise prime notation, this is written as the derivative of uv equals uv prime plus vu prime. In the next slide, I will provide a real-world analogy to help you visualize why we need this specific process, rather than just multiplying the derivatives. Real-world analogy for the product rule. Now, to help you visualize why the product rule works the way it does, let's look at a real-world analogy. Imagine you have a rectangle where both the length, which we will call u of t, and the width, which we will call v of t, are increasing over time, represented by t. Think about how the total area of this rectangle grows. The rate at which the total area changes doesn't just depend on one dimension. Rather, it depends on two things. First, it depends on how fast the length is growing while the width stays constant. Second, it also depends on how fast the width is growing while the length stays constant. This intuition explains why the formula we just discussed in the previous slide requires us to add two separate terms together, rather than simply multiplying the derivatives. Step-by-step application of the product rule. Now that we have established the theoretical foundation and the real-world analogy for the product rule, let's walk through the systematic process of applying it to a mathematical problem. First, you must carefully examine the expression and identify the two distinct functions that are being multiplied together. For the sake of consistency and organization, we will label these two functions as u and v. Second, once you have identified your functions, calculate the derivative of the first function independently. We refer to this result as u prime. Third, follow the same process for the second function and find its derivative, which we call v prime. Finally, we assemble these components using the formula we introduced earlier. You will multiply the original first function by the derivative of the second, and then add that to the product of the original second function and the derivative of the first. By following these 4 steps precisely, you avoid the common mistake of simply multiplying the two derivatives together. To see this process in action, let's move on to a concrete example in the next slide. Example for product rule. Now, let's put the product rule we just discussed into practice with a concrete example. We are asked to differentiate the function f of x equals x squared times cosine of x. Following the step-by-step process from the previous slide, our first task is to identify the two separate functions being multiplied. Let's assign u as x squared and v as cosine of x. Next, we find the derivative of our first function. U using the power rule, the derivative of x squared is 2x. Now, we find the derivative of our second function. V, as we recall from our basic trigonometric derivatives, the derivative of cosine of x is negative sine of x. Finally, we apply the product rule formula, which tells us to take the first function times the derivative of the second, and add that to the second function times the derivative of the first. Plugging in our specific values, we get x squared times negative sine of x, plus cosine of x times 2x to simplify the final expression. We can rewrite this as negative x squared sine of x plus 2x cosine of x. This is our final derivative. Notice how we carefully applied the formula rather than simply multiplying the two derivatives together. As we will see in the upcoming slides, avoiding that specific trap is key to mastering the algebra of derivatives. Now that we have handled multiplication, let's move on to the rule for division. 3. The quotient rule. Now that we have mastered the sum, difference, and product rules, let's move on to our third major rule, the quotient rule. This rule is specifically used when we need to find the derivative of a function that is expressed as a ratio, which is simply a mathematical way of saying one function is divided by another. Let's look at the formal statement. Suppose we have two differentiable functions, u of x and v of x. One critical condition here is that v of x must not be equal to 0, as division by 0 is undefined in mathematics. Under these conditions, the derivative with respect to x of u divided by v is equal to the following expression: v times the derivative of u minus u times the derivative of v, all divided by v squared. To make this more concise, we can express this using prime notation. In this form, the derivative of u over v is written as v times u prime minus u times v prime, all over v squared. Please pay close attention to the order of the terms in the numerator, as we will see in the next few slides that the sequence of these terms is vital to getting the correct answer. Step-by-step application of the quotient rule. Now that we have established the formal formula for the quotient rule in the previous slide, let us break down the process into a systematic, step-by-step approach to ensure accuracy. First, look at your function and clearly identify the two components: the numerator, which we will label as u, and the denominator, which we will label as v. Second, calculate the derivatives of these two functions independently. In other words, find u prime and v prime using the differentiation rules we have already discussed. Third, we construct the numerator of our final result. This is the most critical step where errors often occur. You must take the original denominator and multiply it by the derivative of the numerator, and from that, subtract the product of the original numerator and the derivative of the denominator. Finally, take the entire expression you just calculated for the numerator and divide it by the square of the original denominator. By following these 4 steps in order, you can avoid the common pitfalls of the quotient rule. Let us now apply this process to a concrete example in the next slide. Example for quotient rule. Now, let's put the quotient rule we just discussed into practice with a concrete example. We are tasked with finding the derivative of the function f of x equals sine x divided by x. Following the first step of our process, we must identify the two individual functions. Here, we let the numerator u be sine x and the denominator v be x. In step 2, we find the derivatives of these two functions independently. The derivative of sine x, which we call u prime, is cosine x. The derivative of x, which we call v prime, is simply 1. Now we move to step 3, where we apply the numerator formula. Remember, the order here is critical. It is the denominator times the derivative of the numerator, minus the numerator times the derivative of the denominator. Substituting our values, we get x times cosine x minus sine x times 1. Finally, for step 4, we must divide this entire result by the square of the original denominator. This brings us to our final answer. F prime of x equals x cosine x minus sine x, all divided by x squared. As we move forward, keep this specific order of subtraction in mind, as we will see in the next slide that this is one of the most common areas where errors occur. Common mistakes to avoid. Now that we have covered the 3 primary rules for combining derivatives, it is crucial to discuss some common pitfalls. Even if you understand the formulas, it is very easy to make small mistakes that can lead to an incorrect final answer. First, let's talk about the linearity trap in multiplication. Because the sum and difference rules are so straightforward, many students instinctively assume that the derivative of u times v is simply u prime times v prime. I want to be very clear. This is incorrect. Multiplication does not work linearly. Whenever you see two functions multiplied together, you must always use the product rule we discussed in the previous slides. Next, let's look at the quotient rule. In this rule, the order of subtraction in the numerator is absolutely critical. The formula must be v times u prime minus u times v prime. If you accidentally switch these two terms, you will end up with a sign error, meaning your entire answer will be the negative of what it should be. Always double-check that you are starting with the denominator times the derivative of the numerator. Another frequent error is simply forgetting the denominator. It is quite common for students to spend a lot of time calculating the complex numerator of the quotient rule, only to forget to divide the entire result by v squared. Remember, the derivative is not complete until that denominator is in place. Finally, be mindful of sign errors when working with trigonometry. As we saw in our examples, the derivative of cosine of x is negative sine of x when you plug a negative sign of x into the product or quotient rule formulas. Ensure that you distribute that negative sign correctly across the rest of the expression. By keeping these common mistakes in mind, you can avoid the most frequent errors. Now, let's move on to our final slide to summarize the key takeaways from this lesson. Key takeaways. Now that we have discussed the common pitfalls to avoid, let's wrap up this lesson with a summary of the key takeaways. This slide serves as a quick reference for the 3 fundamental rules we've covered today. First, let's revisit the sum and difference rule. As we saw at the beginning of the lesson, this is the most straightforward rule. It states that the derivative with respect to x of u plus or minus v is simply equal to u prime plus or minus v prime. In short, you just differentiate each term individually and keep the original sign. Next, we have the product rule, which we use whenever 2 functions are multiplied together. Remember, as we cautioned in the previous slide, you cannot simply multiply the derivatives. Instead, the derivative with respect to x of u times v equals u times v prime plus v times u prime. Just remember that this rule requires you to add 2 distinct terms together. Finally, we have the quotient rule, which is applied when one function is divided by another. The derivative with respect to x of u divided by v is equal to v times u prime minus u times v prime, all divided by v squared. Please be extra careful here. As we discussed, the order of subtraction in the numerator is critical, and you must never forget to square the denominator. Mastering these 3 rules will allow you to differentiate almost any combination of functions you'll encounter in your calculus studies.